Hey, so in this video, I'd like to cover a skill that we're going to be using a lot in this class. Even though we won't be using it right away when we get to this subject called stoichiometry, this is going to be something that we do almost every day. Before I get started, I know that the example that I'm going to use in explaining this is something that a lot of you could probably figure out using skills that you already have, but I want to encourage you to make a point of learning this method, all right? Because even though you might be able to answer this question using ways you already know, once we start getting to stoichiometry and we start asking questions such as how many moles of sodium hydroxide would be required to react with 33 milliliters of a 2.5 molar solution of HCl, all right, where you start using terms that you're not familiar with, you're going to have to use this method. All right. I don't know how to teach this through any other way. So I'm teaching the method first so that when we get to using words that we're unfamiliar with, we don't have to learn the method at the same time. So when I talk about this method, I generally use two different terms. I call it widgets and gizmos, but a lot of people will call it crossbars. I've heard some people refer to it as fences. But whenever you hear either crossbar or widgets and gizmos, that's what I'm talking about. All right. So the time that we're going to use this method is anytime you have a question that's in this form. How many of this or are in how many of that? Or another way would be is how many of this would you need if you had that many of that? All right. And you'll start to get a sense of the types of questions that you could use it for the more you practice this. All right. But a simple type of a question that you could ask where you would use this is how many seconds are in 3.52 years? All right. And again, I know that a lot of people could do this even without using this method. But what I want to do is get you used to this technique. All right. So the first thing that we're going to do is we're going to write what are called fractional relationships. And that's where we're going to take relationships that we know to be true, but we're going to represent them in a way that looks like a fraction. All right, so when you look at this question here, what are some of the things that we need to know? All right, well, we need to know, excuse me, that there's 60 seconds in a minute. We need to know that there's 60 minutes in an hour. We need to know that there's 24 hours in a year, and so on. All right, and so all of these relationships we can represent essentially as a fraction. All right, so I'm going to write, instead of saying there are 60 seconds in a minute, I'm going to say that I'm going to put 60 seconds in the numerator, draw a line like it's a fraction, and then put 1 minute in the bottom. And one way that you could say this is 60 seconds per 1 minute. All right, anytime you've got a denominator line, just use the word per. All right, a lot of times mathematically, that's how we can represent speed. We can say like 60 miles per 1 hour. All right, and when you draw it, you make it look like a fraction like this. So the thing about all of these fractional relationships is that even though we wrote it like this, where we put 60 seconds in the numerator, we always have the option of drawing it as the reciprocal. All right, it's like saying there's 1 minute per 60 seconds. Either of these is true. The more that we do these, the more you're just going to choose to write down one of these, and just realize that if you have to, you can turn it upside down and use the reciprocal form. All right, so let's just show the other relationships that we need to know. 60 minutes per hour. All right, 24 hours per day. And the last relationship that you would need is that there are 365 days per 1 year. All right. One thing I want to point out in a lot of these, and this is going to be true when we're doing a lot of these, is that a lot of times you say per one of something. And when you do that, the one that they have here is assumed to mean exactly one. So we could actually replace that with 1.0000 if we wanted to, and that's going to have some significance when we start paying attention to significant figures. Okay, so we're going to now what we're going to do is we're going to construct what we consider a crossbar. All right, and the thing about the crossbar is at the time that you start to construct it, you don't know exactly how long it's going to be. All right, but there's some similarities in all of the crossbars, and the similarities are in how every crossbar starts, how every crossbar ends, and what's in between. All right, so in the beginning of the crossbar, I like to call it, use the analogy and call it an engine, just to make an analogy to a train. All right, every train starts with an engine, every train ends with a caboose, but you can have different number of cars in between. All right, so the thing, what every crossbar is going to start off with is what the question provides you with. All right, so if you look at the question, how many seconds are in 3.52 years? All right, what information is provided for you in that question? All right, that's the 3.52 years. So notice that we draw this long line and we put that information on top of the line. All right, you can go ahead and we're going to put this bar right here to separate that from the other things that we're going to be putting in. And the bottom section is always going to be empty in the engine. So again, that beginning part is the engine. That's what is provided in the question, and we put that here. The last part is the analogy, is I'm going to say that that's like the caboose. And what's going to be true about the caboose is that in the very top right of this, it's going to be what the question is asking for. All right, so if you look at the question, it's how many seconds. All right, so that's going to be in the top right. All right, and when you're doing one of these crossbars, when you start it, you don't know how many steps they're going to be. All right, you're going to have to put some steps in to get from the start to the finish. All right, and what we're going to be doing is just the shortest way to get there. All right, so here's the rules about how to construct this. When you do this, you're going to want to, what we're going to be doing is inserting the relationships that we've created. All right, and we're just going to keep on inserting these relationships in a certain fashion until we eventually get to what the question is asking for. All right, the basic rule that we have to follow, though, is that whatever unit that we have right here has to match diagonally in this fashion right here. So since I've got years right now, right here, I can tell you that I'm going to have years right here. All right, and so what we're going to do is we're going to scan through these relationships right here and see, do we have any of these relationships that has years? All right, this one right here. All right, so what we're going to be doing is we're going to be putting this relationship in here so that I've got years on the bottom. All right, and when I do that, I put year on the bottom, and that puts 365 days up top. All right, I've color-coded these so that we can see that diagonal relationship matching a little bit better. All right, so are we there yet? Well, notice what's in the upper right here. It's days, but in the question we're trying to get to seconds. So we're not done yet. All right, so what we're going to do is we're going to pick another one of these relationships. All right, and the rule that we need to follow is that what is right here needs to match diagonally here. All right, in the same way that this matched diagonally, this has to match diagonally. All right, so where do we see days? Okay, we see days right here. All right, so I'm going to take that and I'm going to put that in. All right, we're still not there. We've got hours in the top right. So we scan looking for hours. All right, and the thing is, the way that these are written, I'm not having to flip any of these over. But in practice, when you're doing this, sometimes you have to flip these over, and you'll see that in the next example that we do. So we're going to take the next relationship that has hours down here. That would be this relationship right here. All right, and that puts the numerator of it up here. All right, and the next one is we need to have diagonally minutes. All right, down here, and you can see that that would be this one. So if I had my choice of these two right here, I would choose this one because this is the relationship that puts minutes down on the bottom, and we need that because we need to have that diagonal relationship. All right. So when you have correctly constructed the crossbar, there's a couple things to check for. First of all, make sure that it starts with what the question provides. Make sure that all of the steps in between have the units which are diagonally matching, like you see here. And once you're done, the thing that's in the upper right is what the question asks for. All right. So what's the whole purpose of putting this in there? All right. It tells you what things that you need to multiply and what things that you need to divide. All right. So if I take all of the numbers that are on top here 3.52, 365, and I just multiply them all together. And then I take all the numbers in the bottom and I just consider those like numbers that would be in the denominator. It tells you the operation that you need to do. All right, so if you multiply all these numbers together and divide them all of these, all right, and again, anytime you see a 1, you can ignore it because multiplying or dividing by 1 doesn't change anything, right? That would tell you the answer to your question. All right, so even though I know that people could do it for this problem, I think it's useful to do this in a way which forces you to use this method. So the reason I call it widgets and gizmos is that I think it's good just to make up these imaginary relationships where I say there's 35 widgets and 3.0 gizmos, and there's 4.2 gizmos in a single thingamajig. All right, so we can take those phrases and we can turn those into fractional relationships like this. All right, I've kind of color-coded things, so gizmos you see here is in green. I see gizmos here, it's also in green. All right, one thing I want to point out, notice the way this is, it says in a single thingamajig. All right, the reason I said single is that would imply that is one and exactly one. All right, when you have a single of something, that's exactly 1, which is the same thing as 1.00000, all right, which is different from saying like 1, like a pound, all right. So that's going to be important because this would be implied to have an unlimited number of significant figures, all right. So, so with these relationships, we have a question: how many thingamajigs are in 200 widgets? All right. First thing that we're going to do is we're going to create a crossbar, and we're going to start it with what the question asks for. And what we need to do is construct this so that we eventually get to thingamajigs. All right, so let's look here. We know that we need to have widgets down here and diagonally, so it's going to be this one, except for when we put it in, we're going to flip it upside down. Okay, so I've gone ahead and put in this relationship, and notice I had to flip it. And another way of saying that is I used the reciprocal of this so that I could have that matching relationship between the units there. All right, so let's check this out. Like, is the question thingamajigs? Is what it's asking for the thing in the upper right? No, we have gizmos. So we need to use another relationship. So I'm going to put a bar in here, and we're going to use the next relationship. And again, we need to make sure that gizmos matches diagonally here. So we're going to have to flip this one right here. All right. And notice there's a strategy to this. Just because this relationship exists doesn't mean I have to use it. The reason I'm using it is it also relates it to thingamajigs, which is where I'm trying to get to in this question here. So I've taken this relationship and I've put it in there in the correct order. All right, so notice this starts with what the question provides. It ends with what the question asks for. And all the relationships that I've put in there are diagonal. All right, and so what this tells me is that the numbers that I need to put into my calculator would be 200 times 3.0. So you take all the numbers from the top, those would be in the numerator, and you're going to put these numbers right here in the bottom. And so you take these numbers and you put them in your calculator, and that's what I get coming out of my calculator right there. And the question is, what do I round this to? All right, so the thing is, you're going to look at the number sig figs. All right, so this right here, that's the purpose of this decimal point in this number. That means this has 3 sig figs. This has got 2. This, remember, would have an unlimited number. All right, so if you can remember this, you can just write down the number 1 there, as long as you remember that 1 means exactly 1 with an unlimited number of zeros. So this one's got 2, this one's got 2 sig figs. So which one has the fewest number of sig figs? Well, there's a couple of them that tie for that. The lowest number that you see in here is 2 sig figs, which means we should round that number right there to 2 sig figs. So that's going to become 0.38. All right, and that's the way that we should report the answer. All right. In the next question, we use the same relationships here, just with a different question. You notice with this, we can get to the answer in one step. All right, so this would be your answer right here with the correct sig figs.